Hello and welcome to question 4 from 2022 Mechanics A2, and it's a wonky moments question again. Now, straight away, just glancing at this, show that, show that, show that. That's kind of nice. At least you know if you've got it right or wrong. So let's get stuck in. Okay, so uniform rod, length 2a, particle mass 2m. Oh, and it's mass m. So let's get the weight on there straight away. So that's going to be mg. And when we get to the point where we go parallel to the bar, we're going to have to know that that's theta, just so we can resolve this force into a perpendicular force. Particle mass 2m is attached at 1.5a, so this is going to be 2mg. That's going to be theta still, and that's going to be a 0.5a 0.5a. It's nice to have that clear. The rod is held in equilibrium at an angle theta to the ground by a light string to attach. The string is light, and so I guess that's a tension in the string. Okay. And now it's on rough horizontal ground, and so we'll have like a contact force there. Let's call it R. We don't need another one because there's no RBs in this one. And now, in terms of this, I guess this must be friction going in this direction. I think actually, just having glanced at this question, this is one of the first questions that we get actually. String is perpendicular to the rod. Okay, explain why the frictional force acting on the rod at A acts horizontally to the right, just as I said it would. Well, the reason it's got to act to the right is because the tension is going a bit to the left. Yeah, if I can move that T over here just so it's in a better place. Yeah, can you see that that's going a bit to the left? It's going a bit up and a bit to the left. Yeah, so I'm just going to say friction has to oppose the component of the tension it's a horizontal component of the tension acting to the left. Otherwise, it wouldn't be possible for these forces to balance, would it? Yeah, and the reason why I know the forces do balance is because it's held in equilibrium. Yeah, and so for a righty force, you need a bit of a lefty force there. Basically, that's all there is to it. Okay, that's going to be an angle theta, purely because if you imagine this being flat on the ground, as you pick it up and move it through theta, well, a straight line will rotate by the same angle theta round here. That's one way of doing it, or you could do it through the other ways. You know, many other ways of doing this. You could dot this down here and say, okay, that's got to be 90 minus theta, because that's theta and that's 90, so that must be 90 minus theta. But then 90 minus theta plus 90 plus theta equals 180, and therefore there's so many different ways of doing those. But yeah, make sure you can do them because it's super important, actually, super important. Okay, so and I want to check. I'm just going to have a quick glance at the mark scheme to see what they said for part A, because I always like to compare, and I strongly encourage you to do this. When you have a wordy question, write your answer down and then compare it to their answer. Now, I'm just looking at my other screen. They've said the horizontal component of T acts to the left, and since the only other horizontal force is friction, it must act to the right. I've pretty much nailed that one. I've got that spot on. But the more you do that, create your own answer, write down your own answer and then compare it to theirs, the more you'll gradually kind of like polish your answers so they're more like answers from the mark scheme for those wordy questions. Okay, let's get into the maths bit though now. The tension in the string is T, so that T equals 2mg cos theta. Well, okay, right, let's have a look at this. We could do uppies equal downies here, I guess, or lefties equal righties, but really the most natural way, because there's no R or F involved, let's take moments at A. Yeah, so for part B, I'm going to take moments at A just because then the equation will only have T and mg in it. Yeah, now these two are both going to turn it in that direction. So you're going to have A times by mg cos theta plus 1.5A times 2mg cos theta. And that should equal 2AT. And that's because T is already perpendicular to the plank. Okay, so once we've got that, cross out all the A's because there's loads of A's which we can just get rid of straight away. And an mg cos theta plus a 3mg cos theta, well that's a 4mg, it's capital M as well, cos theta equals 2t, and therefore 2mg cos theta equals t as required. Cool, so that wasn't too bad. What about C? Given that cos theta equals 3/5, in which case sine theta equals 4/5, because that's going to be a 3, 4, 5 triangle. As you can see here, show that the magnitude of the vertical force exerted by the ground on the rod at A is 57 mg over 25. So it's really saying show R is 57 mg over 25. Yeah? Okay, well, we've taken moments, yeah, which means we shouldn't need to take moments again unless they've changed the situation, yeah, and I can't see that they've changed the situation. So I'm going to say, okay, ups equal downs. So I've got R plus, well, that's going to be T cos theta, and that's going to be equal to 3mg. And R plus, well, we already know what T is, and we know that cos theta is 3/5. And so we're going to have 3/5 times 2, that's 6/5 mg, that's what T is, cos theta. Oh, sorry, no, I've already changed to cos theta for 3/5, I apologise. Because that's 3/5 times by 2, you get 6/5 mg, and then we're going to have to times it by 3/5 again. And that equals 3mg. Okay, so R plus, okay, that looks like 18 mg over 25 equals 3mg. Now, 3mg is the same as 75 mg over 25, and if you take 18 off of 75, you get 57 mg over 25 as required. Okay, so we've taken moments, we've done uppies equal downies, so I guess for the last part, we're going to have to do lefties equal righties, because we need to find mu, and it's in limiting equilibrium, so F is at a maximum here, but we can say F equals T sine theta, yeah? So F equals T sine theta. T, of course, is 2mg cos theta, which is 2mg times 3/5. Sine theta is 4/5. And so what we get here is 1224 mg over 25. And that's F. Well, we know R, we know F, and so we can say F is mu R, because it's in limiting equilibrium, F is at its maximum. So 24 mg over 25 equals mu times by 57 mg over 25. Cross out the 25s, cross out the mg's, and so mu is 24 over 57. Now, if I cancel that and divide it by 3, I get 8. Cancel that and divide it by 3, I get 19ths, as required. Okay, and that was that question. That one didn't seem too bad at all in the end, did it? I hope that was quite nice for you. But once again, notice, what did we do? We took moments, we did uppies equal downies, we did lefties equal righties. It happens in every one of these questions, it really does. Okay, all the best, keep up with the hard work, and yeah, best of luck in the exam. Bye-bye.